This video shows how to build a basic model and execute on different target hardwares. We start by modeling a signal generator and plotting the output on native target. Later on we will show how to route the output of the signal generator to blink an LED on an embedded target. We start by creating a new project. Click on Start button and follow the wizard to create new project. Now create a new workspace file where the model will be developed. Open the block library and drag the pulse generator, signal generator, and plotter blocks to the workspace. For the native target we will try to plot the output of the signal generator. As such, pulse generator block is kept disabled. Connect the blocks and adjust the blocks parameters as per your requirement. It is important to set block name for the plotter block. To allow the plotter block to be placed appropriately in the simulation panel shall be configured with a group and a plotter sub-window. Assign the plotter block to the simulation panel's group and sub-window we just created. Set up simulation settings for native target. By default, limited time non-real-time simulation settings are configured. Press Run button to build the model and run the simulation in a separate simulation panel window. Increase the simulation end time and run again. In the simulation panel you can zoom in the plot with mouse wheel. Left-right panning can be done with left mouse button. You can see the value of the signal by left-clicking on the plot at any time axis value. Now we will modify the simulation settings for unlimited real-time simulation and run the simulation again. Simulation status is indicated in the bottom right corner of the simulation window. The numerator indicates current simulation step time and the denominator indicates system clock from simulation start. In the current simulation, the numerator and the denominator times are equal, indicating that the simulation is running in real time. Simulation speed factor 1 runs the simulation in real time. On native target, speed factor other than 1 can be set to adjust the simulation speeds faster or slower than real time. Now let's run the same model on an embedded target. 8-bit microcontroller board Arduino Uno is selected as current embedded target. Arduino Uno is already connected to the PC and available at serial port COM18. On-board LED of Arduino Uno is connected internally to pin 13. Connect this pin 13 to pin 3 to change the LED brightness with PWM signal generated on pin 3. In the setup simulation, change the target to Arduino Uno and select programmer port as COM18. Configure simulation settings to unlimited time with speed factor as 1. In the model, we start with pulse generator block to blink Arduino Uno onboard LED. Replace the plotter block with target hardware I/O block. Configure the target hardware I/O block as digital output on pin 13. Set the port data type to integer 32 to match with the pulse generator output port data type. Connect the blocks and configure pulse generator block with frequency set to 1 Hz. On clicking Run button, CASP builds the model and programs the board with the generated binary. After the board is programmed, you can see the onboard LED starts blinking at frequency of 1 Hz that was set in the pulse generator block. Now increase the frequency and run again. You can see that the LED is now blinking at the frequency of 4 Hz. Now let's try to change the brightness of LED. For this, disable the pulse generator block and enable signal generator block configured to generate sine wave. Connect the blocks and configure target hardware I/O block to generate PWM output at pin 3. Set the data type as real, to match with the signal generator block output data type. And set the input range from -1 to 1, to match with the signal generator block output amplitude. Run the model and check the LED brightness varying similar to a sine wave. Thank you for watching this video.